Welcome everyone who's joining us this evening for our webinar, Which Engineering Program is Right for You? My name is Daniela Cross and I am the Associate Director of Marketing and Recruitment for the Faculty of Engineering at the University of Waterloo. And I'd like to welcome you and thank you for joining us tonight. Before we begin, I have a few housekeeping notes. If you do want to turn on closed captions, you can click the CC button at the bottom of your screen. It will enable the live transcription. Just so everyone is aware as well, we will email out a video recording of tonight's webinar sometime next week, most likely. If you have any questions, please submit them using the Q&A button at the bottom of your screen. We'll do our best to type responses to all of the questions that are submitted, and then we'll be answering as many as possible out loud after the slideshow this evening. If you do have additional questions that are specific or anything related to admissions that we don't answer this evening, please do email us at enginfo@uwaterloo.ca. I would like to start us off tonight with the University of Waterloo territorial acknowledgement. The University of Waterloo acknowledges that much of our work takes place on the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. Our active work toward reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within our Indigenous Initiatives Office. And if you're interested in learning more about the land that you occupy, there's a great website, nativeland.ca, and it can tell you a bit more about the land that you're on. All right, so tonight we're going to cover off the 15 direct entry undergraduate programs that we have here at the University of Waterloo within the Faculty of Engineering. We have excellent panelists from each of our programs and departments to tell you more about each of them. So without further ado, I'd like to get us started with our School of Architecture, and I'll turn things over to Nicole.
Hi folks, my name is Nicole Gunther. My pronouns are she and her, and I am the program coordinator for the Bachelor of Architectural Studies program. The Bachelor of Architectural Studies pre-professional degree is step 1 to becoming a licensed architect. So I'd like to make the distinction now that this is not actually an engineering degree, this is an architecture degree. The framework of our program is design, which takes place in studio. Our students are designing from day 1. In their very first term, they are participating in design studio 2 full days per week. We find that many of the students that thrive in the program are those that excel and enjoy STEM courses as well as art courses. First year begins with designing smaller spaces like residences and galleries, and as the curriculum builds in complexity in size and scale over the subsequent 5 years, pardon me, students design high-rise urban buildings, cultural projects, and landscape projects. In the final term, all of the knowledge gained over the preceding years culminates into a comprehensive building design studio. At this point, students are designing from the ground up, which includes foundation siting, building envelope, and structure programming. The result of the intense curriculum coupled with the 20 to 24 months of co-op experience allows students to work in architecture firms immediately following the completion of their degrees. The program also features 4 streams that broadens the student experience and all feed back into the main design pillar of the program. These streams enrich the design studio experience and knowledge gained by students. The streams are technology and environment, visual and digital media, urbanism and landscape, and cultural history. And again, these 4 thematic areas all enrich and tie back into the main pillar of the program, which is design. The program also has a very strong international focus. Many of our students travel abroad for their co-op terms. Many of our students participate in international academic exchanges, and in 4th year, the entire cohort travels to Rome, Italy, in our 2nd permanent campus for a semester of learning abroad. Thank you so much for listening, and I look forward to answering your questions.
Thank you so much, Nicole. All right, next up, we're going to cover off our Department of Chemical Engineering as well as our Nanotechnology Engineering program. And we have Professor Ting here to share more with you.
Good evening, everybody. My name is Ting Xu. I'm actually a faculty from the chemical engineering, and I'm also the director of the nanotechnology engineering program. So I'm going to introduce these two programs to you. First of all, I'm going to talk about the chemical engineering program first. So it's applied the principles of science, math, and economics to efficiently transform raw material into useful products. So we do a whole bunch of solve a wide range of industrial and societal problems in a safe, economical, and environmental appropriate fashions. And we also design and to produce, transform, and transport materials and energy. So which means we're talking about new batteries, new type of energy producing methods. So in order to solve the global problems, some of them including, for example, human health, for example, in medicine, vaccines, and also mass productions of different various products. And we also talk about sustainable agriculture, which we are talking about the food, water quality, and quantity. And we also talk about some climate change and sustainability type of technologies, for example, pollution control, and also renewable energy. So there are many different courses covering a wide range of different topics. And for example, teaching you how to make a batteries, a next generation batteries, renewable energies, and also how to use organic material to produce biodegradable polymers, such as using starch as a raw material. So there are many different types of environmental friendly type of technologies going to be introduced. Okay, so next, let's go to nanotechnologies. So what's nanotechnology? Nanotechnology is a multidisciplinary engineering field which draws from and benefit areas from material science and engineering, chemistry, physics, biology, and medicine. And nanotechnology engineers use concepts from biology, chemistry, electronics, and quantum physics to design systems measured in nanometer scale, which is 10 to the minus 9 meter. And Waterloo's nanotechnology programs was first begun in 2005, and is also the first accredited nanotechnologies engineering program in Canada. Roughly, each cohort is about 120 students that will be admitted each year. And students will learn how to model, design, fabricate, and characterize microscopic structures used by a wide range of industries. So for example, integrated circuits, advanced battery design, and also nanotechnology is one of the cornerstones to develop one of the COVID vaccines. Some of you probably know that. And the professors coming from several different disciplines, including chemical engineering, chemistry, and also electrical engineering. And a lot of us teaching those classes in nanotechnologies are also conducting advanced research. So we are going to transfer the knowledge back into the classroom directly from our lab. One of the unique features about the nanotechnology engineering is we have our own dedicated clean room. So this allowed us students to fabricate and design and fabricate the prototypes of different devices. So I'm looking forward to answer any questions.
Thank you so much, Ting. That was fantastic. We're now going to move on to our Department of Civil and Environmental Engineering. And we're going to cover off first architectural and civil engineering. And Shayna is going to cover those slides for us, please.
Hi guys, my name's Shayna and I'm a 2A student in architectural engineering. So architectural engineers sometimes are known as building engineers, design new buildings and adapt old structures with an emphasis on utility, sustainability, and energy efficiency. This program teaches students the use of innovative building materials and technologies. So throughout the degree, students get to participate in a design studio each semester, which are taught by architects and engineers. During the studios, students get to design and work on various projects using softwares like Rhino and AutoCAD. Students also get an opportunity to study in Art School of Architecture in Cambridge in their third year. Some of the optional degrees related to architectural engineering are building structural specialization and building system specialization. As per civil engineers, Without civil engineers, today's cities would not have existed. The degree teaches students how to plan and build long-lasting structures and systems such as airports, bridges, skyscrapers, and municipal infrastructures. Everything from mechanics and stress strain and public safety to hydrology are covered in the course of this program. Some of the optional degrees related to civil engineering are geotechnical specialization, structural specialization, transportation specialization, and water resource specialization. I would love to answer any of your questions that you may have at the end of the presentation. Thank you.
Hi, my name is Jason, and I'm going to talk a little bit about environmental and geological engineering. So I'm currently in my 4A term of geological engineering. Environmental engineering involves applying engineering design principles to environmental issues to create a more sustainable environment. Waterloo has a really strong background in water research dating back a long time, which can lead you into a wide range of careers in the job force and also in future studies at Waterloo or elsewhere. Some of the main fields of water studies include watershed restoration and water treatment. Many graduates discover career fields related to environmental engineering in workforces such as consulting engineers or government bodies. And they mainly act to protect the environment, such as reducing air pollution, reducing groundwater contamination, or reducing surface contamination. You can take 3 optional specializations with your degree in environmental engineering. The first one's hydrology, the second one's energy, and the third one's pollution treatment and control. So geological engineering involves understanding and managing the complexity of the earth in order to perform engineering tasks with it. So the earth is very complex and often you don't have a lot of data about it. So making proper engineering decisions is very important. You'll learn to design structures and anything with earth really, on soil, rock, water, and wind. Students will work outside a lot, just as a nature of the problems that you're solving. So if you enjoy working outdoors, this would be a great field for you. If you choose your electives right, you can, or if you choose certain electives, you can work as both a professional engineer or professional geoscientist after graduation. There's a lot of different careers you can do. Consultants, you can work for mining companies or government bodies as well. And the 3 specializations you can take with geological engineering are geology, hydrogeology, and soils, rocks, and structures. If you have any questions, I'm happy to answer them at the end. And yeah, so this Venn diagram shows some of the similarities and differences between the 4 programs in CEE. So we can see that there's a lot of overlap between all 4 of the programs. A lot of your courses that you'll take as a civil or an enviro will be with other programs, such as geological engineers. So even if you just choose one program, you'll still get sort of an introduction to the other areas of study.
Thank you so much, Jason and Shayna. That was a great overview of the Department of Civil and Environmental Engineering. We're now going to move on to the Department of Electrical and Computer Engineering, and we're also going to cover the software engineering program. So I will turn things over to Amanda.
Hi everyone, I'm Amanda. I'm a 2A software engineering student. And like Daniela said, I'm going to talk to you guys about the ECE department. So the first program within ECE that I'm going to talk to you guys about is computer engineering. So in computer engineering, students will do a mix of designing hardware and also learning how to do software systems. They're working on how the hardware and software interact, how these systems will impact users, and how they can perform in real-world settings. The next one is electrical engineering. So electrical engineering works mainly with the hardware. So like it says on the slide, learning to design more efficient and reliable technologies like wind turbines, GPS, robotics, and other things like that. But electrical engineering also works with communicating with those hardware systems. So doing control systems and computer systems are also things that they work on. And lastly, software engineering is a program that's jointly offered by engineering and computer science. And students will learn how to build software and algorithms and design human-computer interfaces and optimize software. So I'm sure many of you are wondering what's the difference between computer science, software engineering, and computer engineering, because they all sound very similar. And so you can see on the screen, there's quite a few differences, quite a few similarities. Some of the main differences are, so computer science is offered through the math department. And so there, since they have fewer like required courses like we do in engineering, they have a more flexible course load. They're able to have a 4-year program with no co-op, or they can pick to have a 5-year program with co-op, where in software engineering and computer engineering, you have a fixed course load and fixed schedule because you have a lot of required courses, and it is a 5-year co-op program. As well, computer science focuses more on the studying of software. Computer engineering will focus on the mix of creating software and also creating hardware systems. And software engineering focuses more on creating software systems. And lastly, there's just a little Venn diagram just to show you a little bit more about the differences and commonalities. So CS works with a lot of high-level programming. So they'll do topics like data science, talk about the theory of programming. As well, both CS and SE will cover topics like user interfaces and proofs. SE will focus quite a bit on software architecture and software testing. CE and SE both have circuits courses, and as well we have science courses. Because we are an engineering program, we do take science courses. And computer engineering will surround things like chip design and robotics. Something that CE and SE have that CS doesn't is our cohort system. So that's something that all of our engineering programs have. So since our programs have so many required courses, we group together all the students taking those courses, and basically you will be taking classes with the same group of students until you graduate, which personally I really like because I feel like it helps to build a good sense of community with you and the other people in your program. And all of the programs, CE, CS, and SE, all cover software and creating software, and also all have co-op.
Excellent. Thank you so much, Amanda. That was a great overview and a lot to cover. We are now going to go into our Department of Management Sciences, and I'll turn things over to Ada.
Thanks, Daniela. Hi, everyone. My name is Ada Hurst. I'm a faculty member in the Department of Management Sciences, which is the one that offers the management engineering program. I've been teaching courses for over 10 years now in this program. So I want to start by saying that the program is very different from what most people likely imagine when they hear the words management engineering. So many people might think that it's a combination of business and engineering, or they might assume that it's a program that teaches you a little bit about each other engineering program so that you can become an engineering manager. So these are, I would say, incorrect sort of descriptions of the program. So then what is management engineering? So what management engineers do is they improve business processes and decisions in a world that is increasingly digital and data-centric. And what management engineers do is design management systems. We also call these decision support systems. So these systems capture, process, and use data to improve processes and decisions in industry. Just to give you a very quick example of what these decisions might be, consider, for example, an airline industry or an airline company that needs to decide where they should offer their flights, when they should be scheduled, how they should price the tickets. So there's lots of decisions that use lots of data. So obviously the program is very data driven, very math heavy, but it's also very human centric. I think this is a really nice and interesting aspect of the program that perhaps distinguishes a bit from some other programs. So the users of these management systems or decision support systems are people and organizations. So it really matters understanding how people think and how they behave. So with all of what I've talked about so far, basically you need a pretty distinct skill set, which relies on a very interdisciplinary program. And this program applies and integrates three main core areas. So the first one is data analytics and operations research. So this is a lot of applied math and data science. The second one is software information systems. So what this really means is computer programming, but also things like human-computer interaction, and then later on in upper years, even things like search engines. And the third smaller area is organizational science. So these are courses in psychology and economics. There's about 3 to 4 courses in this topic. So all in all, I would say management engineering provides a really excellent training, and these skills are really in high demand in industry. So we know that our graduates, both in co-op, but also after they graduate, they work as analysts, consultants, technical product managers, data scientists, software developers, and more. And the program has really, we've been very impressed by how it's maintained a really high co-op employment rate and also post-graduation employment rate, even during the pandemic, which I think it really speaks to how useful and how broad the applicability of these skills is in industry. And so our students and graduates work really in any industry, from software and high tech to finance, supply chain and logistics, healthcare and manufacturing. So I'm happy to answer more questions through the Q&A later on live. But also if you have any questions about the program after this session, I'm happy to answer them via email. So I'll just put my email in the chat, and thanks again.
Thanks so much, Ada. That was fantastic. And we will go over now to our Department of Mechanical and Mechatronics Engineering. And we have a current student with us this evening, Andrea, who will tell us more about this department.
Thanks, Daniela. So hi, everyone. My name is Andrea. I'm a third-year mechatronics engineering student. And I'm going to start off with, I guess, explaining about what mechanical engineering is. So mechanical engineers use their technical skills and their knowledge of mechanics, fluids, and energy to create new technologies. So students typically design and build machines and devices that extend off of the physical capabilities of humans and improve the quality of life. So for example, a mechanical engineer would use tools such as AutoCAD, SolidWorks, various machining skills to design these systems with moving parts, whether it's creating a simple component to fit through an entire system, or whether it's putting the entire system together. So graduates from this program work in many different industries, but most of them include, some of them include aerospace, automotive, manufacturing, and green energy. So now going into mechatronics engineering, this one's a little bit different, and a lot of people, I think, often are confused as to what it actually is. It's a mix of systems design, mechanical, and then electrical and computer engineering. So it's basically putting together little bits and pieces of all those types of engineering together to design, build, and test computer-controlled electromechanical systems. So it's taking the mechanical portion, the electrical portion, putting it together to create a system. So Waterloo's mechatronics engineering program was the first accredited undergraduate program in Canada to focus on mechatronics. And a lot of the work that we do is based upon robots, satellite systems, drones, autonomous vehicles, so much more, really anything that combines the electrical, mechanical parts together, which a lot of systems nowadays do combine. So students apply skills and knowledge during co-op placements, working in tech, automotive, manufacturing, and aerospace companies. So very excited to answer your questions at the end.
Awesome. Thank you so much, Andrea. That was great. We will now go to our Department of Systems Design Engineering, and we have Professor Brian Tripp here to cover off biomedical engineering and systems design engineering. Over to you, Brian.
Hi, everybody. Brian Tripp. I'm a professor in systems design engineering and director of the biomedical engineering program. So biomedical engineering encompasses all kinds of medical equipment. So any sort of hospital equipment, including defibrillators, all the way up to MRI machines and so on. That's all biomedical engineering. Also assistive devices, like hearing aids and so on, implants, hip implants and active implants like pacemakers, all that kind of stuff. The program also, in the course of sort of preparing you for that whole sort of category of things, you'll also learn all the right stuff to get into designing athletic equipment. So we actually have a specialization in sports engineering as well, which isn't core biomedical engineering, but it's closely related. So a couple of distinguishing features of the program. We have a heavy emphasis on design. We have a lot of design courses, and we try to give you a little bit of biomedical engineering in each course. So sometimes it's not a lot, just to sort of, we try to draw most of the examples from biomedical engineering, and other courses are of course totally biomedical engineering, but we try to sort of give biomedical engineering content all the time. And I've these points are reminding me to mention that biomedical engineering is not intended to prepare you for medical school. So that's a misconception that I think some people have. That's not to say you're not allowed to go to medical school after biomedical engineering, but it's not really common. We have maybe 1 or 2 people a year that do that, but it's not, the program doesn't really specifically prepare you for that. Okay, so let's go to the next slide then. Systems design engineering is in the same department, and actually, I guess I should mention our biomedical program has sort of a systems design flavor, as other programs in high schools have slightly different sort of leanings. So systems design presents sort of a big picture approach to solve interdisciplinary problems, and of course, there's an emphasis on design. On engineering design. We have a design course in every term. So you get 8 design courses. So really a lot of exposure to engineering design principles. The systems part is probably a little bit harder to pin down. It takes a little while to get used to sort of, what the systems aspect of the program is. But it involves big picture. A system is really just anything with parts that interact with each other. So our sort of perspective tends to focus more on interactions than sort of a lot of detail about any really drilling down to one part out of hundreds in a system. A nice thing about the program is that you can select from a lot of different elective courses. We give students a lot of flexibility in choosing electives and sort of building their own degree. Students go on to do work in lots of different fields. Okay, that's all. And I'd be happy to answer questions, of course.
Fantastic. Thank you so much, Brian. I'm now going to cover off a little bit about engineering co-op. So all of our engineering programs do involve co-op. And during co-op terms, students can explore different careers and employers. So it's a really great way to get work experience, up to 2 years of full-time work experience in your field of study. Successful completion of 5 of 6 co-op terms is required to graduate. And most co-op terms are 4 months in duration. Co-op earnings in Canada range anywhere from $8,400 to $21,000 per co-op term. So it really depends on your year and your program, what those ranges are. And over 1,500 students participate in international co-op placements every year during a typical year. Obviously, the pandemic had a bit of an effect on that, but our students are definitely getting back out there. And as you can see on this slide, this was the locations of the engineering co-op positions in 2020. So in spite of the pandemic, we still did have students working all over the world. We also had a 92.4% employment rate, over $117 million in co-op earnings. And you can just see some of the other data there. There was over 2,245 engineering co-op employers in 2020. So there are a wide range of co-op positions available. And I know our students who are our panelists tonight would love to answer more questions about co-op if you have them. And then just so you understand how the study and work sequences work, you're either in a Stream 4 or a Stream 8 program. Stream 8 just simply means that your first year of study, you would have back-to-back study terms, and then you would go into your alternating work and then study terms. So you're either on co-op or you're on a study term, is how it works at the University of Waterloo. And then finally, just steps to getting a job and having a successful co-op experience. There's a co-op fundamentals course that our students take. Students will upload their resume to a system called Waterloo Works and apply to the co-op positions through that system. They'll attend interviews, so sometimes they'll be in person, sometimes they'll be virtual. And then students have the opportunity to rank potential employers after they've done the interview, and then the employers will rank the student. So the matches happen based on that ranking system. And then you start your job and you're off to an amazing co-op experience. Okay, and now we are going to turn things over to our Director of Engineering Admissions, William Bishop.
Thank you, Daniela. So first, I'll start by saying that the Waterloo Engineering Admissions team recognizes that the global pandemic has had a profound impact on the opportunities available to high school students as they prepare to apply to university. We will consider all applicants in the context of the current situation, and we endeavor to assess each applicant fairly. Next slide. So here's the list of the required courses in the Ontario school curriculum. Of course, if you're studying outside of the Ontario secondary school curriculum, we list all of the requirements on our website, and I encourage you to check those out. There are 5 required courses: advanced functions, calculus and vectors, chemistry, physics, and English. And then we take into account 1 additional 4U or 4M course. Students are required to have a minimum final grade of 70% in each of these courses. And for admission consideration, students have to have an overall average of 85% in the 6 courses that we use for the admission average. Of course, if you're a student applying to software engineering, it's important to demonstrate that you have programming experience. Of course, this can be demonstrated in various ways. Grade 11 and grade 12 programming courses can, of course, demonstrate programming experience, but you can also demonstrate this as well by participating in programming contests, online courses, and other significant programming experience, such as programming for a company on a co-op work experience. A lot of students have questions about the admission information form. It is required that you complete this form for admission consideration and scholarship consideration. It's your opportunity to tell us a little bit more about you. In particular, we're interested in what your motivation for studying engineering is. We want to know about any extracurricular activities and enrichment courses you may have done. I know a number of students have asked about IB and AP courses. That's a way that you can indicate that on your application. I'll also point out that extracurricular activities can be defined in a very wide sense. Basically, anything that you do outside of your school can be considered extracurricular. We, of course, look at work and volunteer experience as you're preparing for a co-op program, and of course, awards and achievements. And one thing a number of students have asked about is, can they apply to a second program? And the answer is that you should list this as your alternate engineering program on the admission information form if you're interested. In general, we say that a well-written AIF will significantly improve the likelihood that you'll be admitted to the program that you're interested in. We also have an online video interview. Completion of this interview is highly recommended. It's viewed as optional for admission consideration, but it is a requirement for our entrance scholarships. We find that students that complete the interview significantly do better on the admissions. In general, it improves the likelihood that you will be admitted to the program of your choice. The interview really consists of 2 questions that examine why you want to study engineering and why you're a good fit for the program you've applied to join. And for each question, applicants are given a short amount of time to compose and record a video response. So We've done a lot of evaluation to find out how often students get into our programs. And generally, most of our engineering applicants have an average in the low 90s to mid 90s. But of course, we do have some engineering programs where a mid 80s average will get you into the engineering program. We also, have, of course, have some high-end programs where a high 90s average may be required. The admission information form and the online video interview obviously play a critical role in the selection of applicants. And it's important to remember that no admission average will guarantee an offer of admission. Here we see a slide out of our brochure that illustrates the probability of acceptance into various programs. We've grouped them by their competitiveness from the standpoint of admissions. Biomedical and software engineering are the two most competitive programs to get into. And generally speaking, you have to have a 95% average to have a reasonably good probability of acceptance. As your average goes up, of course, the probability of acceptance increases. And if you go to my blog post that I put out yesterday on theroadtoengineering.com, you'll see a graph that illustrates how the averages and the probability of acceptance are related. The second group is computer, electrical, mechanical, mechatronics, and systems design. If you have a 95 average, you have a very good chance of getting into these programs. And if you're in the low 90s, you still have a decent chance of getting into the programs. Obviously, there's some variation. The programs are not all the same because we're grouping together 5 programs here. Generally speaking, the electrical program is probably a bit easier to get into, say, than the systems design program, for example. And then the bottom group, which are still excellent engineering programs and quite challenging programs, these ones have a higher probability of acceptance simply because of the fact that they have more spaces available compared to the demand for the programs. We have architectural, chemical, civil, environmental, geological, management, and nanotechnology in this category. And a student with a 90 average would have a very good chance of being admitted to the program. And even a student in the 85 to 89% average range would generally have some chance of being admitted to the programs. It's important to remember that in a typical year, we have 14,000 applicants apply to Waterloo Engineering. About 4,000 of those applicants will be offered admission. So that's slightly less than 30%. And then 2,000 of the applicants will accept an offer of admission. About 1,800 students will register for first year classes. In terms of when our decisions are made, they're made in 2 rounds for the University of Waterloo for the Faculty of Engineering. First round happens at the end of March, and the final round happens in the middle of May. We put out about half of our decisions in the first round and the remaining decisions in the final round. Outside of these rounds, we do occasionally make admission decisions on a case-by-case basis, but that's rare, and usually it's the result of a student needing to have an answer because they have a pending financial commitment for another university that's prior to the next round. So a popular question is, how will IB and AP courses be treated? Obviously, these courses are touted by high schools as being better preparation, and in many ways they are, and in some ways they're not. It really depends upon the school. One thing we cannot do, unfortunately, is allow for transfer credits for engineering programs. And that's because of the fact that we go through an accreditation process with the Professional Engineers of Ontario and the Canadian Engineering Accreditation Board. And all of our courses have to be delivered at a post-secondary level. And to prove that, we have to allow visits from external visitors. It'd be very difficult to have these external visitors visit every high school, obviously. So what we recommend is that students that take IB courses and AP courses should inform us about their studies on the admission information form, and we'll look at the individual case to decide whether there's any sort of adjustment required. Another hot topic is whether listing Waterloo Engineering as your Your first choice will give you an advantage over listing as your second or third choice. The answer is that applicants who list our engineering programs as their first, second, or third UWac choice will be treated the same. Essentially, we're going to assess students based on their qualifications, not based on how they rate us. Another hot topic has to do with program transfers. Because we're a direct entry engineering program, we offer a little bit less flexibility than some of the general first-year programs offered by other Ontario universities. It's often difficult to transfer from one program to the next, and a lot of that has to do with the fact that we tried to prepare students early for their co-op experiences, and in doing so, we have to offer specific courses that are discipline-specific, and it's going to be difficult to get those courses if you are in an advanced term. So transfer approval often requires not only space availability and good academic standing, but also transfer applicants may be required to repeat a year, delaying graduation by a year. So in general, we tell students to do their homework before applying to the University of Waterloo. Make sure that the program that you're applying to is one that you would be willing to complete. And the best way to find that out is actually to talk to students and find out exactly what the students are doing and whether that's something that would interest you. And just a note about repeated courses. Repeating a required course only makes sense for the University of Waterloo engineering programs if you have a required course below 70%. Because if you're in that situation, you would not be eligible for admission. So by repeating a course in that situation, you then become admissible to our program. But it's important to realize that when you do repeat a course, there's an adjustment applied, and the adjustment is significant. So unless a suitable explanation is provided, the admission average will be adjusted basically by 5%, which is equivalent to deducting 30% from a course grade. So it's important to remember that you don't want to repeat a course unless you have to. If the original grade, of course, was 70% or higher, to not penalize students in the admissions process, we'll actually use the original grade rather than the repeated grade and not apply a repeat penalty. It's also important to note that if you repeat a required course, that can make you ineligible for entrance scholarships. And a hot topic is required courses in the final quadmester or trimester or semester or octomester. There's all different systems this year. If we are looking at students, we use whatever grade of information we have available at the time. Basically, before each admission round, we take a snapshot of the grades that have been submitted to us. And when a required course grade is missing, we will predict a grade in that course. If we have interim grade information or predicted grade information available, we'll use that information. Otherwise, we'll predict the course grades using other available grade information. So perhaps we'll use a grade 11 course, or we may have to use another technique if we don't have a suitable course to predict with. Now, admission offers are always given out to applicants that are missing required course grades at the time of admission consideration. It's very common in the first round that applicants will be missing final grades in required courses. We obviously are in the business of trying to figure out whether you're going to do well in those courses or not. And for those students that may be relatively new to English and are looking for a bridge program, if you're weaker in the English language, we have two programs available. One is iBase and the other is BASE. These stand for the Intensive Bridge to Academic Success in English and the Bridge to Academic Success in English. These programs generally work very well for students who are relatively new to studying in the English language. The iBase program allows students to start immediately in their undergraduate program as scheduled. They basically do a 7-week program prior to the start of their studies to get up to speed. The BASE program is for students that have weaker English language skills, and in that case, students delay their program by a year to take the BASE program, where they do an 8-month BASE program at the start. Both these programs are highly successful, and if you're offered one of these programs, it's a great way to get into Waterloo engineering and be successful. Another hot topic are English as a second language course. If you've taken an English as a second language course, either ESL or ELD in the Ontario Secondary School curriculum in the 2 years prior to the request start date, you'll be flagged for an English language proficiency test. The reason being that students that typically take ESL or ELD courses are weaker in English, and we want to make sure that your proficiency is at the right level. So for fall 2022 applicants, if you've enrolled in any ESL course or ELD course in fall 2019 or later, you'll be asked for an English language proficiency test. We will email that request in February to request submission of the test scores. But if you're in that situation, if you know you're in that situation at this time, I highly recommend planning an English language proficiency test prior to that date so that you have the test score ready to go. Thank you.
Thank you so much, Bill. That was fantastic. And I know we do have a number of admissions related questions for you. So we will get to those within the Q&A. Just before we start that, I did just want to cover a few of the upcoming webinars and events. So we would encourage everyone to attend the virtual fall open house that's taking place on Saturday, October the 30th. All of our faculties will be represented at that event. There will be presentations. Each of the faculties and student groups and student areas will have booths. So it's a great virtual event to get to know more about the University of Waterloo. And a number of the people that you've met this evening will actually be there for engineering as well. Then if we do have any guidance counselors on the call, or if you want to let any of your guidance counselors know, we're hosting a couple of webinars on November 3rd and 4th that are specifically for guidance counselors and how they can help support their students through the application process to engineering and math. Then on November 17th and November 18th, and then again on January 11th and the 13th, we are running an admissions tips and tricks webinar. So you probably only need to attend one of each of those series, and we'll be covering off some of the things that might be helpful as you're applying to Waterloo Engineering. So the URL is there, as well as that QR code that you can scan that will take you to the registration page. And then just really quickly, these are some of our social media channels. We do encourage you to follow us on social media. We've got a lot of great student-focused content on there, especially our YouTube channel, Instagram. So check us out, and we'd love to see you join us there. And then just finally, as Bill did mention, a great way to learn more about our programs is by chatting with engineering student ambassadors. So these are students, they're current students who are happy to do a virtual conversation with you to cover off any questions that you might have. So the link is there to register. You can just Google UWaterloo Eng Chat or Waterloo Engineering Eng Chat, and the link will come up to register for one of those sessions. As I mentioned earlier, you can always email us at enginfo@uwaterloo.ca. And then we also have live online chats that are run centrally through the University of Waterloo. So you can check those out at uwaterloo.ca/futurestudents/chats. Okay, so we are going to move into our Q&A panel now. So if all of our presenters could go ahead and turn on their cameras, we will get right into that. And I know we've got a number of great questions, so we'll try to get to as many as possible this evening. Okay, so I'm going to start off with Andrea from MME. Andrea, we had a question come in about aerospace and what opportunities there are for someone who might be interested in aerospace within the mechanical engineering program.
Absolutely. I know a lot of friends of mine who are very interested in aerospace, and mechanical engineering is a great place to start for that. Unfortunately, I don't think there are any specific courses related to aerospace just specifically, but there's a lot of different other courses which touch upon different topics within aerospace, and it's a perfect stepping stone to get into a master's program for aerospace engineering and things like that. So I think mechanical would be a great place to start off your aerospace journey. And a lot of my friends have also done co-ops in aerospace companies. Bombardier is an example. So there's a lot of opportunity to pursue that field for sure.
Okay, that's awesome. Thank you so much, Andrea. Next question is for Jason. So Jason, could you tell us what some of the key differences are between geological and environmental engineering, and which program do you feel is the most flexible of those two?
Yeah, so environmental engineering deals with more environmental issues related to the surface. That's one way of thinking about it. So for example, they deal with air quality, also groundwater quality and river flow. So those are sort of the three general main areas. Geological engineers more focus on the subsurface. So they'll focus on designing things in the subsurface, forces and stresses in there, and also some groundwater. So groundwater is one of those areas of overlap. Environmental engineering is much more chemistry, I would say, than geological engineering, whereas geological engineering is more earth sciences and just regular science classes. So that's one difference. And then in terms of flexibility, I would say environmental engineering probably offers more flexibility just because you can take a broader range of courses also in different departments. So there's some mechanical engineering courses you can take in subjects like thermodynamics and different things like that. You can take civil engineering courses related to transportation, and also the regular environmental engineering courses and earth science courses more similar to geological.
Okay, that's fantastic. Thanks so much, Jason. I'm going to go over now to Nicole. And Nicole, I'm wondering if you can tell us a little bit more about the differences between the School of Architecture program and architectural engineering. And we also have Shana here, who is a current architectural engineering student as well, in case we want to expand on that.
Thanks, Daniela. I'd be happy to. So the architecture program is a pre-professional accredited program. So it is the foundation to becoming an architect. Course content is totally focused on design right from day one, and all courses relate back to design. So this includes technical and structural courses, cultural history, environmental and landscape, visual and digital media. The architectural engineering program sets students on a path to become an engineer, not an architect. Course content wise, the program is actually closer to civil engineering rather than architecture. Courses will cover content on mechanics, structural analysis, and structural design, as well as heavy math content in the first 2 years. Shana, maybe you can cap it off with some student experience.
I think what you said was perfect. It's more architectural engineering is more heavily science and math based, and I think architecture focuses a lot more on design. I think you're good for that.
Fantastic. Thank you so much. And Nicole, for a student who does apply to the School of Architecture, what are some of the things that they should include in their portfolio? Just architecture focused materials, or what could they be thinking about including?
Yeah, absolutely. So what we recommend to our applicants is to include anything in your portfolio for how you show your creativity skills. That could be you make sculptures. So maybe you're taking a picture of a sculpture and including that in your portfolio. Maybe you participate in photography, or you like to build models, or you do pottery. What we don't want to see is architectural designs. We will teach you that in school. What we want to see is how you show your creativity. And something that we recommend applicants often do is also bring their sketchbooks as a part of their portfolio, because that will show part of your thinking process, how you think through problems.
Fantastic. Thank you so much, Nicole. I now have a question for Ting. Ting, could you expand a little bit on the types of jobs that nanotechnology engineering students have, the types of co-op jobs that they get while they're in the program?
Oh, there's many different jobs you can go into. Many students go overseas, go to different universities to perform research. So they sometimes, actually, a few of them publish paper while they are in co-op jobs. And some of them went into the industry, of course. You can work in the microelectronic industry, so you can design chips. Sometimes you can actually fabricate chips. Some of them actually went to pharmaceutical industry, as I mentioned before. For example, COVID vaccines require some nanoparticles in it. So it's also a great industry to be in the pharmaceutical industry. And some of them, surprisingly, actually went to Wall Street. Actually, I want some folks have a great time in Wall Street because apparently they like the engineering discipline on risk assessments, which is also highly demanded for those high fund managers, I guess. So there's a wide range and very diverse fields and a lot of applications, as you can see, in different areas, pharmaceutical, microelectronics, you can do research, or even go to fintech, which is a financial technology, also highly demanded. Also because engineers has a lot of mathematical skill, so which is also very highly demanded in the financial industry.
Awesome. Thank you so much, Chang. So many options, many exciting options within nanotechnology. Okay, and now a question for Ada. Ada, could you explain the difference between industrial engineering and management engineering?
Sure. Yeah, that's a great question. So industrial and management engineering, there are no other management engineering programs in Canada, but it actually is very similar to industrial engineering. We like to think of it as a modernized industrial engineering program. Some of the courses are based on very fundamental industrial engineering principles. But I think what sets it apart from a lot of other industrial engineering programs in Canada is the heavy focus on software and information systems. So our students will take programming courses beginning in their 1B term, so the second term they're in the first year, and then all the way to end of third year, with possibility of taking more in their fourth year. So there is more focus on information and software systems and more focus on data analytics. But the program is it's quite similar to industrial engineering programs, probably very similar to industrial engineering at the University of Toronto, very different perhaps from industrial engineering at some other universities. Okay. We actually have a page on that, so I'll put the URL in the chat, and that might be helpful as well.
Okay, that's fantastic. Thank you so much, Ada. Brian, I've got a question for you now, and maybe you can answer this for both programs. What are some of the careers that graduates of systems design engineering go into, and what are some of the careers that grads of biomedical engineering go into?
Sure. Let's see. So, I mean, for biomedical, the things you'd expect, I think. So, medical devices, probably normal. So I guess biomedical is one of the programs that there's sort of more of a tendency to go into graduate school. So a bunch of our students always go to graduate school. A small number go into medical school. It's probably more than other engineering programs, though. There's a very large interest, I think, in both programs, sort of growing probably in software and AI topics. So, more medically based, obviously, for biomedical engineering. Systems design engineering is all over the place. I'm having a hard time pinning it down. One thing that might not be obvious is a lot of students in systems design are interested in sort of UI and user interface, user experience, cognitive ergonomics kinds of things, which may not be sort of obvious. We have some electives in that area, and students, they're not all of them, but a substantial fraction, I think, take a strong interest in it and go in that direction. So I hope, that's I'm sure I'm forgetting a lot of things, but that's a smattering anyway.
No, I think that was great. That was very helpful. And just so our attendees know as well, we do have student pages on the future students section of our website that list out careers for each of the engineering programs. So if you're interested in where you might end up, there's some careers that are listed on each of those pages as well. So that's great. A question now for Amanda regarding software engineering. What would you say would be considered sufficient programming experience? So when you were applying to software engineering, maybe what kind of software or programming experience did you have? And maybe what have you heard some of your peers had when they were applying?
Yeah, definitely. There's so many kind of different levels of like programming experience out there. For me, I took CS courses in my high school. I also did some learning by myself. So there's all kinds of different options, like taking courses in your high school, taking courses outside of your high school. So if there's kind of like a local organization that's like after school hours that teaches CS, you could do that. You could do some self-learning online. There's a bunch of free courseware. Waterloo actually has one from the CS department. I'll send the link in the chat. I really love it because it really starts from the basics, but then also teaches you some really incredible stuff like recursion. That's definitely very helpful for your first year. For me, for my cohort, having programming experience wasn't required. It was heavily suggested. Now it's required. But because of that, so people do have different levels of programming experience. There's people who have been doing hackathons for like 8 years and they're just experts, and some people who come in who've had no experience whatsoever. But in your first year, they really start you off with the basics, then kind of build up to the more intense programming, the recursion, the algorithms, and they definitely work to kind of make sure that you're able to know what you're doing, what the basics are. And so if you have less programming experience, don't be scared. But I would definitely say in like the summer before you go off to university, try and do some learning by yourself and do some of that like open courseware just to kind of keep it fresh in your brain and help you kind of hit the ground running when you're in your first year.
Fantastic. That was great. Thank you, Amanda. Bill, we have a couple of admissions related questions for you, if I could turn things over to you for a moment. So can students apply to more than one engineering program? I guess they're asking at different universities on their OUAC form. And then can they apply to programs in other faculties at the University of Waterloo on their form?
Okay, great. So the Ontario University Application Center will allow you to apply to 3 engineering programs at 3 different schools. That's not a problem. So if you want to apply to computer engineering at the University of Waterloo, computer engineering at the University of Toronto, and computer engineering at Queen's, you could certainly do that. Of course, you can only apply to one engineering program at the University of Waterloo, and you can list an alternate program on your admission information form. The second question you had, can you just remind me what it was?
Can a student apply to programs at within other faculties on their form if they apply to engineering?
Sure. So absolutely, you could apply to computer science, which is of course offered by the math faculty in the School of Computer Science. You could apply to computer engineering or software engineering, and you could apply to accounting and financial management within the School of Accounting and Finance, for example. So you could apply to 3 programs at Waterloo, as long as they're in different faculties, for example.
Okay, and could a student, for example, apply to the School of Architecture and Architectural Engineering?
Yes, they can actually do that because the School of Architecture is treated separately. They have quite a different admissions process. They go through an in-person interview that way.
Okay, fantastic. So another question for you, and maybe we can also ask some of the students this. What are some of the things that students should include on their AIF, and what do you consider to be an extracurricular?
So first, I can make the comment that extracurricular activities or any activities outside of the classroom. A lot of students sometimes define it narrowly as activities that they've taken through the school system, but it doesn't have to be. So if you're in a community league for athletics, maybe a basketball team, a soccer team, list that as an extracurricular. If you have a hobby such as music, or if you participate in local theater, list that as extracurriculars. Work experience, volunteer experience, anything quite honestly is beneficial. Basically, when we evaluate extracurricular activities, we're looking for anything that you could list on your resume that might be of interest to a co-op employer. And sometimes they're interested in some very unusual things. I remember once there was a a co-op student who got a co-op job at a company because he listed he was a goalie on his high school hockey team. And it turned out that the company he went to work for, they needed a goalie on their corporate team. So when all the students were basically equal, they said, hey, we can get a goalie this way. So you never know what will be of interest to a co-op employer. So definitely anything, volunteer work, hobbies, sports, arts, anything that you do is of interest.
Fantastic. And if I could ask our students, if you'd like to share something, you don't all have to, but Andrea, maybe if I could start with you, what were some of the things, if you can remember, that you included on your AIF that might have been something that wouldn't occur to somebody to maybe include?
Right. So I think I was a child in high school that did a lot of volunteer work. So I was the one who was like always volunteering every weekend. And you don't normally associate volunteering and mechatronics. I feel like a lot of people would think that because I chose mechatronics, I would be putting in like robotics teams, or I did coding competitions or hackathons, but I really didn't do any of that. I did a lot of music. I did volunteering, leadership, community, things like that. I volunteered with Girl Guides of Canada, my local religion school. So there's tons and tons of things that you can put on your resume or on your AIF that would also help for your resume. I'd also mention that try to think of how that activity has helped you develop as a leader. So I think one of the questions that I saw come up was, what would you count as leadership experience? And my personal philosophy is that everything counts as leadership experience if you can pick out what you gained from it. So whether it was volunteering, you led a group of students on an activity, whether you led a team to win a championship, things like that. So wanted to put that out there.
That is fantastic. Thank you, Andrea. Okay, I've got maybe one more question for Bill, and then we may try to wrap things up. I know it's getting a bit late here. So Bill, I know you talked a little bit about our offer timing. Can you just tell us again when offers go out, and does engineering do any early offers?
Yeah, so we have an early admission round, but that's of course still admitting students for fall of 2022, which is the only time we admit to engineering undergrad programs. The admission offers in the early round will go out at the end of March. So typically, you know, by the last day in March, if you've gotten one of the early admission offers. Don't be surprised if you don't get an early admission offer, because half of our students do not get an early offer. So that's important to keep in mind. The final admission offers typically go out in the second week of May. Obviously, we try to get them out as quickly as we can, and we're somewhat subject to when we get data from the Ontario University's Application Centre. So we try to turn around the decisions as soon as we can, but it can vary.
Okay, fantastic. The last question I have for our panelists, and if you do want to say anything, just unmute yourself and then I'll know to come to you, is what advice you have for a high school student who might be struggling to choose the program to apply to, especially when at Waterloo, we can apply to one program and indicate an alternate on the AIF. Any advice you have if a student is in that position? And I will just do one quick plug for our engineering program compatibility quiz. So I know Erica has shared the link there in the chat with everyone. But we do have a great quiz that will help guide you through a series of questions that will give you some potential options that you may wish to consider based on your interests. So please do check out that quiz. It could maybe be helpful. Amanda, I'll start off with you, please.
Yeah, so some things that I found really helped me, not to plug engineering ambassadors, but definitely reaching out to students who are in that program, I found was amazing. Back when, you know, we were in person pre-COVID, I was actually able to come and shadow a software engineering student for a day. So I went with him to his classes. I was chatting with him and his friends in between classes, and that was really cool because it showed me what they're learning. I got to hear from the students what they liked, what they didn't like, and that really played a big role in me deciding software engineering. Also, something that I'd suggest is Googling like the program you're looking at, like software engineering course calendar, UWaterloo, And what will come up is all of the required courses for that program. And that's definitely really helpful because then you can go in and look at the courses that you would be taking if you were in this program. Then you can see if there's courses there that really interest you, or maybe ones that don't really interest you and you don't want to take, and then look at a different program. I think it's definitely really important because like the descriptions of all the engineerings online can sound great. They can also sound kind of vague. So that gives you a little more insight into what you would actually be learning and what you would actually be studying.
Excellent. Thank you so much, Amanda. Did anyone else want to add to that? Just any advice for a student when they're making their decision as to which program to apply to? I think we've covered some great things tonight. Brian, did you want to add anything?
Well, yeah, I just want to agree with Amanda, especially so I've had students shadowing in my courses, and it's I don't know, I always feel like it's overwhelming for them because they come in, not it's halfway through the term, and you just sort of, everybody else has been sort of prepared for weeks for the lecture, but anyway, they seem to soak it up pretty well, and I think it seems like a really positive experience. And reading the calendar stuff, yeah, all the descriptions for each program, you get a list of all the core courses. You see when your electives are. If you click on the links for the course numbers, then you get to a brief, 2 or 3 sentence description of the course. So that's, I mean, it's not a full description of the course, but it's enough to take in. If you go through the programs you're interested in, I think you get a very specific idea what's going to happen.
Thanks, Brian.
All of which just, yeah, I just agree.
Yeah, no, that is great. And just regarding the shadow program, things are opening up quite a bit more. And in January, I know we will be restarting our engineering specific tours, and hopefully some of our other offerings as well. So right now the campus tours are available, and we can share a link in the chat there to the campus tours. Maybe Erica can share that. So we do have some limited generic campus tours happening, but as of January, the specific faculty tours will start up again. So if you're close enough to come to Waterloo, you can do that. We do have a really good virtual tour video online as well. And definitely check out the Eng chats. We've got a great program. Andrea is one of the key ambassadors who's helped us set that up in the virtual space. And it's a really awesome way to have one-on-one contact with student ambassadors and really ask those questions that you might have about our programs. All right, well, I want to thank all of our panelists so much for joining us tonight. You've been fantastic and answered so many questions. And thank you to our attendees. We really appreciated you joining us this evening. And you asked a ton of great questions. I hope we were able to cover most of the things. But once again, you can always email us at enginfo@uwaterloo.ca and check out our websites as well. A lot of the info will be there that you're hopefully looking for. Thanks so much, everyone, and have a great evening. Take care.